Today we're going to talk about part 2 of the hyperbola. The things that you need to know about the hyperbola, specifically the eccentricity, how to find the foci, and the parametric form for the hyperbola. First, we're going to start with some review. The main difference between the hyperbola equation and the ellipse equation is the fact that the hyperbola equation is subtraction. X minus h, the quantity squared, over a squared, minus y minus k squared over b squared equals 1. Now, think about this for a minute. Which way does this hyperbola open? Left and right, or up and down? And how do you know? This one opens left and right because of the fact that the x fraction is positive. That's how you know. In order to do the one that opens up and down, you don't switch the a and the b, you switch the numerators because the y fraction has to be the positive one. So this one is y minus k squared over a squared minus x minus h squared over b squared equals 1. Now notice this time a is not always bigger than b. A is always the first denominator. So a is always the first denominator. First thing I want to talk about is the foci. Now the foci for this one are inside the curves like so. They're not between them, they're inside of them. And so in this case, C has to be bigger than A because A and C are on the same line. The way to find the focus is the formula c squared equals a squared plus b squared. For the ellipse, it was subtraction. For the hyperbola, it is addition, and that's what makes c bigger than a. And as a reminder, c and a are on the same line. And that was true also for ellipses. A is the distance from the center to the curves in either direction. And c is the distance from the center to the focus in each direction. The eccentricity for a hyperbola, and remember that e is always greater than 1, and it is found by this formula. E equals the square root of 1 plus b squared over a squared. And that's how you calculate the eccentricity. So let's do an example of finding these new features. I want to find the center, the vertices, the foci, and the eccentricity for the following problem. And this one involves some completing the square. X squared minus 3y squared plus 36y plus 6x equals 108. Now in order to do this, we have to complete the square like we did in the Hyperbolas 1 video. We need to put the x's and y's together. Notice these are slightly out of order, so make sure you do it carefully. X squared plus 6x plus blank to finish that one off. Since there is no leading coefficient on the x squared, it doesn't need a number out in front. However, the y squared has a -3 in front, so that must come out. Now remember, when you bring that out, of course, this is now just y squared, but the term that comes after it involves this 36. Now notice this is positive 36. You must think -3 times what is going to give you positive 36. And do you know what that number is? That number is going to be -12. So this is y squared minus 12y plus blank, and then 108 plus 2 blanks over here. Now we're ready to factor. This has to be the same parentheses that they have to add up to be 6, so these are 3 and 3. So this will be x plus 3, the quantity squared. The number that goes in the blank is 9. The number that goes on the other side is also 9. Now for the next pair of brackets, y and y, I have -12 in the bracket, so this needs to be -6 and -6. The number on the blank is a positive 36. However, the number on the other side is not a positive 36. What is it? It is -3 times 36, which is -108. So to finish up this last line here, This is negative 3y minus 6 squared equals, now on the right, the 108's cross out, and I'm left with just 9. Is this in graphing form? The answer is no. The graphing form on the right-hand side has to equal 1. So the way we do that is we divide each term by 9. So this now becomes x plus 3, the quantity squared, over 9, minus y minus 6, the quantity squared, over 3, equals 1. So now I have my graphing form. So what I'm going to do is put over on the left what I'm looking for. I'm looking for the center. I'm looking for the vertices. I'm looking for the foci. And I'm looking for the eccentricity. This is where my final answers are going to be. Over the right side is going to be my workings. So carefully tell me the center. It's going to be negative 3 and positive 6. In order to find the vertices, I need to find A, B, and C. I really don't need C for the vertices. I need it for the foci. What is A and why? A is 3 because it is the square root of, not the bigger denominator, the first denominator. Because the first denominator is a 9, A is 3. B is the square root of 3. Since we don't know what that is exactly, we can just leave it like that. C then, remember, is going to be found, C squared first, is the two denominators added together, 9 plus 3. So C squared equals 12, and you can just leave C as the square root of 12. Or you can change it to a decimal. It's up to you. Okay, now, how many vertices does a hyperbola have? It only has 2. The vertices are here and here, and that is A units from the center based on the direction of opening. Now, because this one has x as the positive fraction, this one does open left and right. So we are going to add the A value. We add it to the x coordinate because it's under the x. So that's going to be negative 3 plus or minus 3 comma 6 for the vertices. So there's my workings, and I'm going to write them up here. Negative 3 plus 3 is 0 comma 6. Negative 3 minus 3 is negative 6 comma 6. So there are my two only vertices. A and C, I wrote up here, are on the same line. So whichever you added your A coordinate to, you also add your C coordinate to. So we add this to the x coordinate as well. So that means it's going to be negative 3 plus or minus the square root of 12 comma 6. Now, I can't add those two values together, so I can just write it as negative 3 plus the square root of 12 comma 6 and negative 3 minus the square root of 12 comma 6. Just separate them into two separate sets of brackets. Finally, the eccentricity. The formula is the square root of 1 plus b squared, which is 3, over a squared, which is 9. So that cleans up to be 1 plus 1/3, which is the square root of 4/3, and you can just leave it like that. Now moving on, let's talk about the parametric form. The parametric form for hyperbolas. First set of equations looks like this. X equals h plus a secant of t, y equals k plus b tangent of t. Now think about it for a minute. Which way do you think this one opens and why? Remember that A determines the direction of opening. And notice that A is with X, so this one is a X direction opening. It is left and right. Now for the up and down one, H, do you think H and K would stay in the same place? The answer is yes, because H is tied to X and K is tied to Y all the time. Now the one big difference here is that the A and the B are tied to their trig functions. So the B is going to go with X, and the tangent is also going to go with X. And then A secant of t is this way. So this one is up and down. Now, unlike the ellipse, where cosine always goes with x and sine always goes with y, here the two trig functions, the trig function is tied to its coefficient. Those two have to stay together. So keep that in mind as you write your problems down. So let's do a sample problem of one of these. We're going to write the parametric form for the previous problem. So this was x plus 3, the quantity squared, over 9 minus y minus 6 squared over 3 equals 1. All right, just like the ellipse, we need 4 pieces of information. We need h, we need k, we need a, and we need b. And I believe you can find all 4 of those off of this problem. So take a second and do that. Pause the video if you need to. Now the question is, which way does this one open? This one opens because x is first, it's left and right. So you're going to use the top set of equations. But actually, I'm going to do this without even looking at those equations. I'm going to remember that it's x equals and y equals. The h goes with the x, the k goes with the y. Now, a and secant go together. Who gets the a, the x or the y? The a goes with the x because it's under the x fraction. So this will be 3 secant of t. This will be square root of 3 tangent of t, and we're finished. Now, if you didn't follow all of my logic with that, that's okay. Use the guide of the 2 formulas up here to know how to write the last half of the problem. I think all of you can write the fact that -3 goes here and 6 goes here with h and k. It's the other 2 parts that might be a little tricky. Just make sure that you get them in the correct order. Okay, that's the lesson. The assignment is going to be, in the Griffith book, you're going to be doing section 1.6, which is on page 16. Do either the odds or the evens. In the Delta book, this is section 2.05, which is on page 42. All right, good luck with this lesson, and let me know if you have any questions.